Welcome back, everyone. In this video, we're going to learn about Dalton's law of partial pressure and use the partial pressure of a gas to find the total pressure of a mixture and relate that as well to the mole fraction of a gas. So what is the partial pressure of a gas? Well, we must understand that when we have gases that are mixed together, they actually behave independent of one another. Remember that there are no intermolecular forces that exist between the gases. Therefore, they behave as though the other gas were not present in terms of interacting and the pressure that it exerts. So the partial pressure of a gas is the pressure that a given gas would exert if it were alone in a container. So Dalton's law of partial pressure states that the total pressure within a container is going to be the sum of the individual partial pressures. And this should make sense because each gas is independent of the others. Then the total pressure is just the sum of the independent parts. Now, we can talk about these gases in terms of their mole fraction as well. And the mole fraction of a given gas or any substance is its fraction of the total. For gases, this is both in terms of moles and pressure. For substances that are not gases, we'll evaluate that only in terms of the moles. So the mole fraction of any given gas is equivalent to the ratio of its number of moles over the total moles, or for gases, for the gas of that pressure, the partial pressure, over the total pressure. Again, the partial pressure of each gas is proportional to the total fraction within a mixture. And all of this comes into effect because gases do not exert intermolecular forces on each other. So let's take a look here at an example. Let's say that we have one gas, and in total, it has a pressure of 1 atmosphere. If we, when it's inside this container, if we then evacuate that container and put in a second gas, let's say that because of the number of molecules of that gas, it also exerts 1 atmosphere of pressure. So independently of each other, they both exert 1 atmosphere of pressure. So when we put both of those gases into that same container, then our total pressure is simply the sum of the individual partial pressures. And then in that case, the mole fraction of each gas would be 0.5, since you would take the partial pressure over the total pressure. Let's practice. The vessel described below contains 5 different gases. We want to know what's the partial pressure of oxygen inside the vessel. Pause the video and try and determine this on your own. Welcome back. So, if we want to find the partial pressure of any gas, we can relate the mole fraction of that gas to the total pressure inside the vessel. We know that the sum of the mole fractions must add up to be 1. And the reason for this is because any fraction, when part of a whole, must add together to give us unity, or 1. Since we're looking at a collection of different gases, each of them will add up together to give us a mole fraction or a value of 1. So in order to find the mole fraction of oxygen, we account for the mole fractions of the other 4 gases and then solve for oxygen. This gets us a mole fraction of 0.1. What this means is that the oxygen makes up 10% of the total number of gas molecules inside the vessel. To find the actual partial pressure of oxygen, we multiply the mole fraction times the total pressure. And that gives us then a value of 75.6 torr. Let's try another problem. If we have 1 gram of neon and a gram of helium that are added to 50 milliliter vessel at 25 degrees Celsius, what's the partial pressure of helium inside the vessel? Pause the video and try this on your own. Welcome back. So if we want to find the partial pressure of a given gas, remember that because they are independent of each other, we can find the pressure of one gas without accounting for the presence of the other gas. So because we know the temperature and the volume and the mass, we can compute the pressure of a given gas by using the ideal gas law. Again, we can do this for one substance at a time. So to find the pressure, we rearrange our ideal gas law. And let's say that we want to solve first for helium. We can do this by solving first for the moles of helium. We know there's a relationship between moles, mass, and molar mass. And so we take the mass of helium, divide by the molar mass, and that will cancel out units of grams and leave us with moles. We have about 1/4 of a mole of helium. We know the temperature is 25 degrees Celsius, but we need to convert that to Kelvin. And then the volume is in milliliters, which we need to convert to liters. We're now prepared to use these values in the ideal gas law. We have our moles of helium, the ideal gas law constant, the temperature in Kelvin, and the volume in liters. Note here that your units should cancel out. We should be left with units that are pressure-based. We see that our pressure then is about 120 atmospheres. You could do a similar calculation to find the partial pressure of the second gas by using the mass of that gas. That's it for this video. Thanks for watching. Have a great day.